Have you ever stopped to think about the most amazing, most complicated thing in the entire universe? Well, chances are you're using it right now. Today, we're taking a look inside the human brain.
I mean, think about it. This thing, it's only about 3 pounds of squishy tissue, but it creates literally everything you experience. Every sight, every sound, every idea, every feeling. So the big question is, how? How does it do that? That's the mystery we're going to start to unravel.
All right, so first things first, let's get the lay of the land. Before we can understand the software, you gotta know a little something about the hardware. Now, when you picture a brain, you might just think of it as one big, wrinkly blob. But it's actually way more organized than that. It's split up into different sections, or lobes, and each one has its own very specific job to do.
So up front, you've got the frontal lobe. This is like the CEO of your brain. It's in charge of your personality, making plans, and decision-making. Then there's the parietal lobe, which is kind of like your body's navigation system, helping you understand where you are in space and processing stuff like touch. The temporal lobes, right there by your ears, well, they handle hearing, obviously, but also a lot of memory. And way in the back, you've got the occipital lobe. That's the visual effects department. It takes everything your eyes see and turns it into a picture of the world.
And this isn't just, textbook theory. This stuff is real. For example, if someone has a serious injury to their frontal lobe, their entire personality can change. A calm, responsible person might suddenly become impulsive and totally unreliable. It's a pretty powerful reminder that who we are is physically rooted in the health of this amazing organ.
Okay, so we've seen the big departments. Now let's zoom in, way, way in, and meet the little guys who are actually doing all the work.
So your brain is basically made up of two main types of cells. You've definitely heard of neurons. They're the rock stars, the messengers, zapping signals all over the place. But here's the thing, they can't do it alone. They have this essential support crew called glial cells. The glia are the unsung heroes. They provide food, they clean up waste, they give the neurons structure. Basically, they make sure the rock stars can put on the show. And the scale of this operation is, well, it's just mind-blowing. You have something like 86 billion neurons in your head. And each one of those connects to thousands of others. That incredible, chaotic-looking light show of electrical signals, that's you. That's a thought happening.
So we've covered the parts, big and small. Now let's see how they work together to actually produce a behavior. And we're going to start with one we all do, but almost nobody really understands. Yawning seems simple enough, right? You get tired, you open your mouth wide, you yawn. But in biology, asking why is never quite that easy. Turns out there are a few different ways to explain even the simplest behavior. So we could look at it from a physiological angle. That is, how do the muscles and nerves actually make a yawn happen? Or we could ask an evolutionary question. Why did our ancient ancestors yawn? And why did that trait stick around? Then there's the functional explanation. What good does it do for us right now? Some scientists think it might help cool the brain down. See? 3 totally different kinds of answers for one simple yawn. And this whole idea of explaining behavior, it leads us to a much bigger, much deeper question. Okay, the brain makes us yawn. But what about our inner life, our consciousness? This is what philosophers call the mind-body problem. For a long time, the most popular idea came from the philosopher René Descartes. He came up with something called dualism. And honestly, it feels kind of right, doesn't it? It's the idea that your mind, your consciousness, your you-ness, is like a non-physical ghost living inside the physical machine of your brain. But that's not how most neuroscientists see it today. The modern view is something called monism, and the idea here is that there's no ghost. The mind and brain aren't two separate things. The mind is simply the product of what the brain is doing. Your thoughts aren't separate from your neurons. Your thoughts are your neurons firing. Simply put, the mind is what the brain does. Okay, I know, that is a huge claim. It's one thing to say it, but is there any way to actually see it? To feel it? Well, yeah, there is, and it's a really cool illusion we can explore right now. This is an effect called binocular rivalry. So here's the setup. Imagine we could show your left eye only these red vertical lines, and at the exact same time, show your right eye only these green horizontal lines. So your brain is getting both signals, constantly and simultaneously. But here's the wild part. You won't see a plaid pattern or some weird mix. Instead, your conscious awareness will literally flip. For a couple of seconds, you'll see only the red lines, and then pop, you'll see only the green lines. It just goes back and forth and forth. even though nothing you're looking at has changed at all. So what on earth is going on? Well, your brain is making a choice. It's deciding which image gets to be your reality at any given moment. It's flipping a switch on what you perceive.
This is such a powerful demonstration of monism. The physical signal coming in is constant, but your subjective experience is changing. And when scientists put people in brain scanners while they do this, they can actually see the activity in the brain shifting in perfect time with the person reporting, okay, now I see red, okay, now I see green. It's a direct link between what the brain is doing and what you're experiencing. And yet, we're still not at the bottom of the mystery. The philosopher David Chalmers makes this great point. He says we're getting really good at the easy problems, like mapping out how the brain processes information. But we still have no clue how to solve the hard problem, which is, why does all that processing feel like anything? Why isn't it all just happening in the dark without any conscious experience at all? And that leaves us with this massive, kind of spooky final thought. If we really accept that the mind is what the brain does, well, what happens when we finally build a machine that can do what a brain does? If we make an artificial brain, will it have a mind? Will it be conscious? That question used to be pure science fiction, but now it's getting closer to science fact every single day.